Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2018 Maths Methods Exam 1 for the Northern Hemisphere. So yeah, let's start with this video. Before I start, guys, if you guys want private tutoring, like always, please make sure to email me down below. And yeah, we can discuss that there. Let's get this video done now. So question 1, let f of x equal this, find f dash of x. Okay, so this is u, this is v, so we're going to use the question rule. So f dash of x is just x squared minus 3 ex minus ex 2x all over x squared minus 3 squared. We can take the common factor of ex out, we can get x squared minus 3 minus 2x all over x squared minus 3 squared. And yeah, that's the answer for that one. Hope that's right. If you guys, if there's a wrong answer, please make sure to comment it down below. I will have a look at it. Yeah. So let y equal this. Okay, so this is u and that's v. When x is, okay, so we're going to use the product rule here. So dy dx, x plus 5, 1 on x, plus log ex, 1, okay. And we know that dy dx, when x equals 5, is 10, 1 on 5, plus log e 5. That'll be 2 plus log e 5. That's for that one. Question 2, f of x is this, g of x is that, find this. Okay, so what's first f on 3? That'll be 9 here, plus, so 3 plus 4, 7, so negative 2. So what's then, we're saying what's g negative 2? That'll be 4 minus 2, 2. Yep. So therefore g f on 3 is just 2. That's that. Express the rule of f g of x in the form of this, where a and b and c are non-zero integers. Okay, so f g of x is just putting g of x in every x. So we're saying x squared minus 2 squared plus x squared minus 2 plus 4. That'll be x to the power 4 minus 2 x squared 2 plus 4 plus x squared minus 2 plus 4 minus x 4 plus 4x squared minus 4 plus x squared plus 2 negative x4 plus 5x squared minus 2. So express it in this form, and yeah, that's that, where a and b are non-zero integers. That looks good. Evaluate from 0 to 1 this. This is nice and easy, so this will be, so 0 to 1, ex minus e negative x dx will be ex plus e negative x 0 to 1. Okay, which will be e1 plus e negative 1 minus e0 plus e0, so e1 plus 1 over e minus 2. And yeah, that's that. So just e plus 1 over e minus 2. That's that for that one. Is that right? Yep, looks good. Solve this. Okay, very nice and easy. Log 3 t squared minus 4 negative 1 3 negative 1 t over 2 squared minus 4 1 on 3 t squared minus 4, so it'll be t squared minus 4 3t, so t squared minus 3t minus 4 equals 0. T, we get 4, 1. So 1 minus 4, negative 3. Perfect. So that works. So we can rewrite this as 2 minus 4, t plus 1 equals 0, so t equals 4, and t equals -1. We do have to exclude that -1, because if we sub in a -1 on that t, a log is always positive, and we have to exclude. So we can say this one's wrong, so t equals 4. As why is that? Because we can say that t is greater than 0. Yeah, as t is greater than 0. That's that. So this is the only solution. Question 5. If h of x is this domain over here, state the range. So I'm just going to graph this quickly. Alright, so at x equals -2, so we'll have here. And at x equals -3, right over here. Oops. Y equals -3. And it will look like a nice positive parabola. Okay. Well, the domain says that all reals, including 0. So we're excluding all of this. So this is all excluded, and all of this is excluded. And this is included right there. So your range of h is what? It's -3, not included, to this point over here, which is, if I sub in 0, so 7 over 2 minus 3, so that'll be half. Is that right? Yep, half. So half and half is included. Alright. State the rule for h inverse. So what we have to say is that we want to let h of x equal y, and we want to interchange x and y. So therefore we will get x equals 7, y plus 2, minus 3, x plus 3, 7, y plus 2. So we get y plus 2, 7, x plus 3, 7, x plus 3, minus 2. So therefore your h inverse of x is 7 over x plus 3 minus 2. That's your rule. The discrete random variable x has a probability mass function this. So show that 1 over 12 is this. Okay, these are distinct points. They're not actually like a continuous, like the normal. So, okay. Let's sub in 1 first. So it'll be k plus, let's sub in 4. It'll be 4k. Let's sub in 6. It'll be plus 6k. And we also have this one, which is, 3, but that doesn't have any x, so it's just plus k. And that should all equal 1. That will be 12k equals 1, so k equals half. Find the expected. Okay, so what I'm going to do here, because it's like distinct points, I'm just going to draw a normal, like the probability table here. And say this is here. Okay, this is not the best, but like let's say this is your x and this is your probability of x or something like that. So this is 1. This is 3, 4, 6, and we know that probability of 1 is what? It's just k. 3 is k, 4k, 6k. So the expected value we know is just multiplying these and adding them together. So it'll be k plus 3k plus 16k plus 36k. And this is your expected value. So what's that? 20k plus 36k. So what's 30? That will be 56k. And we know k is what? 1 over 12. Which is, so if we half all of these, so it's 28 over 6. And we halve that again, so it'll be 14 over 3. That's that. That's your expected value. Find the probability of this given this. Okay, so I'm just going to draw a nice this and say this is 3 and this is 2. And this 3 is greater and this one also is greater. Well, the intersection happens at, so probability of x is greater or equal to 3 all over probability of x is greater or equal to 2. And probably if x is greater or equal to 3 as well. So if we go here on this table, it's these pretty much. So it'll be 11k all over. Probably if it's greater than 2, it's still these 3 actually. So it's 11k. So 11k is just 1. That's your probability. So yeah, that's that. Question 7. So 0 to pi over 2 f of x is this, and g of x is this. Okay. Sketch the graphs of f and g on the axis below. Okay. So, well, the first one, f of x, is just what? Well, it's a cos graph. So it happens here, and it touches the x-axis here. So if I'm going to nicely draw one, it's going to have to look, and what about if we sub in pi on 4 too, so we can get the exact value. So 4 times, so cos pi over 4 is what? It's 1 over root 2, which is just root 2 over 2. So 2 root 2. That's around this. So around this part here. So if I'm nicely going to draw a nice and smooth curve here, like that. And we'll do that for the sine one. So sine has amplitude of 3, so I'm drawing this. And the max occurs here, so it will occur around this value here. And so it's going to look like this. Perfect. Sketch the graph of f, and okay, so we don't have to label anything, so yeah, just that. And I would just, for safety, I would just say that's g of x, and this one is f of x. Let C be such that f of c equals g of c, where c is between 0 and pi 2. So that's c is the intersection. Find the value of sine c and the value of cos c. Okay, so because we know fc equals g of c, let's try that. So we're saying that for cos x must equal 3 sine x. Okay, if I divide both sides by cos, we'll get 3 tan of x. So if we divide that, so so that'll be 4 on 3 tan of x. So if I draw a right angle triangle, say that's C here, and we know that's 4 on 3 because that's your opposite, the adjacent, and so this has to be 5 by using Pythagoras theorem, but this is a perfect triangle, right angle triangle. So now we just need to find sine c is what? It's opposite over hypotenuse, which is 4 over 5. And cos c is what? It's 3 over 5. And yeah, they are positive because c is in the, it's pretty much in the first quadrant. It's at this first quadrant over here where they are all positive. So yeah, those are nice. That was a nice question for 3 marks. Wow. Good. Let A be the region enclosed by the horizontal axis at the graph of f and the graph of g. Shade the area, so shade the region A on the axis provided in part A, and also label the position of C on the horizontal axis. So because C is the intersection, so C would be this part over here. C would be this. And we need to also, this is the area. Right over here, this is the area that we'll be finding out. Nice. Done. So we've shaded it, and yeah. Calculate the area of A. So, okay, area is what? Well, from 0 to C, so from 0 to C, the upper function is g of x. So we can say, all right, what's g of x? So g of x is 3 sine x dx plus from C to pi on 2, it's 4 cos x dx. Is that right? 4 cos. All right, perfect. So now let's simplify that. So that'll be sorry, excuse me. So that'll be negative 3 cos x from C to 0. Is that right? Yep. So plus 4 sine x pi over 2 c. And that will be negative 3 cos C minus negative 3 cos 0 for sine pi on 2 minus 4 sine C. Alright, so simplifying that, so we're going to say negative 3 cos C plus 3, because cos 0 is 1, plus 4 sine is just 1, so plus 4, minus 4 sine C. What do we know? We know cos C is what? Cos C is 3 over 5, so we're saying negative 3 over 5 plus 7 minus 4 sine C 4 over 5. And that'll be negative 9 over 5 plus 7 minus 16 over 5. So that'll be negative 25 over 5 plus 7, which is negative 5 plus 7, which is 2. So that'll be 2 units squared. Alright, that's good. That question's good. That's done. Alright. So, question 8. Let P be the random variable that represents the sample proportion of customers who bring their own shopping bags to a large shopping center from a sample consisting of all customers on a particular day, an approximate 95% confidence interval for the proportion of P of customers who bring their own shopping bags to this large interval for shopping center was determined to be this. Find the value of P that was used to obtain this approximate 95% confidence interval. Okay, so 1 mark. So what I'm going to do is if I sketch a nice graph here, your P value would be here, P dash, and this is your confidence interval. It's these, one is over here and the other one is over here. So what do we know? Well, it's just if we add both of these and divide them by 2, we should get your P, your proportional. So let's add them together. So if you add those together, so wait, 4. So yeah, I can see what they've done here. If you add them together, that's 10,000 all over 50,000. Cancel those out. That'll be 1 over 5th. But remember, multiply by half. So remember, we add those two and we divide it by half. So multiply by half. So your P dash equals 1 on 10. That's that. Use the fact that 1.96 is 49 over 25 to find the size of the sample for which the approximate 95% confidence interval was obtained. Okay, so we know that P, a P value, use the fact to find the proportion for, use the fact to find the size of the sample for which this approximate 95% confidence interval was obtained. Okay, because we know that it's P to this plus Z, which is what, 49 over 25. 25 with the square root of P1 minus P this all over N. So we're going to use this formula and we're going to equate it to this one because we use the positive. I mean, you can use the negative and you can use this, but I'm going to just use the positive. I think it just makes life easier. I'm just going to 1, 2, 3. Okay. So what I'm going to do is we know P is what? 1 over 10. So we can say that 1 on 10 plus 49, 25. What's 1 on 10? 9 on 10 all over N. Okay. So just let's look at the square root here. I'm just going to do some quick calculations. That'll be 9 over 100 divided by N, which we can just say it's square root of 9 over 100 N. That'll be 3 over 10 root N. So just simplify this here. So that'll be times 3 10 root N. Okay. That should all equal to 5147 over 50,000. Alright, I'm just going to bring this one over here. So it'll be, what's 49 times 3 first? 49, 3, 9, 18, 27, 4, 8, 12, 13, 14. So 147 over 250 square root 9. Bring that 1 over 10 to the other side, so it's 147 over 50,000 minus 1 on 10. So it'll be 5147 minus 5,000 all over 50,000. That'll be 147 over 50,000. So we can say this is 147 over 50,000. All right. Now, we can cancel those out. So it's just 250 root n over 50,000. Let's cancel one of those o's out. So it'll be root n over 25 divided by this. So 200. Okay. Square both sides. So what's 200 squared? It's 200, 200. 0, 0, 0, 0, 0, 0, 0, 0, 4, 40,000. So 40,000. Damn! That's a lot of calculations for that question. Wait, how many marks? 2 marks! Oh my god, that's not worth 2 marks. That's just too much. A lot of algebra, and the numbers like are not. They're ugly because. Like, oh my god, they're not, I don't know how to answer this. I don't even know how to rate this question, actually, because I don't know. I don't know if it's, like, it's alright, but it's too much, like, for that. That's that. Is this the last question? Please tell me. Yes. Okay. The diagram below shows a trapezium with the vertices 0 to 0, which is over here, 0 to 2, which is here, 3 to 2, which is here, and this over here, where b is the real number, and between 0 to 2. On the same axis as the trapezium, part of the graph of the cubic polynomial function is drawn. It has a rule this, where a is a non-zero real number. So 0, x is between 0 to b, at the local maximum, so this over here, of the graph y equals b. So here, alright, so equals b. This one over here, b. And they're saying find a in terms of b. Okay. Let's find this value of this maximum. Well, we know the minimum is at b, but let's try to find the maximum. So if we find dy dx, that's u and that's v. So we can say, ax, bring that 2 there, x minus b, plus x minus b squared a. We want to let this equal to 0. Let's simplify that more. So 2ax x minus b plus a x minus b squared equals 0. Let's take a common factor of x minus b out. So it'll be 2ax plus a x minus b equals 0. And we know x equals b is the actual minimum value, so we don't need to worry about that. So we want 2ax plus ax minus ab equals 0. So x is 2a plus a equals ab. X is 3a equals ab. So x is equal to b on 3. So this value over here is b on 3. Knowing this, I'm just going to make this little because it's too much working out. Okay. Knowing this, I'm going to... Okay. So we know that when y... So we know that when... We know it's b. This coordinate here is now b on 3, b. So we can say b is equal to AB on 3. Yep. And b over 3 minus b squared, so that's ab on 3. So that's b minus 3b on 3, so negative 2b on 3. Squaring that, so it'll be 4b squared or 9. 4b squared over 9. Let's rub that out. So b is equal to what? 4a b to the power 4, power 3 actually. 27. And what can we also determine? We can cancel those, one of those, so it'll be b's out, so it'll be 1 over 4ab squared for 27. So find a in terms of b. Yeah, so now what does that mean? So we need to find a, so it'll be 27 4ab squared, so it'll be 27 over 4b squared, or a. So yeah, so a equals 27 over 4b squared. Hope that's right. Yeah, that's that. Alright. Wow. Next question. The area between the graph of the function and the x-axis is removed from the trapezium as shown in the diagram. Show that the expression for the area of the shared region is this. b plus 3. Okay. If I split this here, split this nicely. Here, if I can just look at this right over here, this is nice and symmetrical. It's pretty much this area. If I can just easily find this area of this rectangle, it's the same as this area. So that's good to know. So let me just find this area of this, which is what? Half 3 minus b, 2, which is just 3 minus b. So this area over here, pretty much this area, I just found this area, 3 minus b. That's good. I'm just going to write this and just say it's 3 minus b. Plus, let's find this area of this. I don't know if it's a rectangle or triangle, but yeah, let's find this area of this over here. This whole area of this whole thing, which is what? It's b. It's 2b pretty much. 2b. It's 2b minus the area from 0 to b of the function ax x minus b squared, so minus b squared dx. That, yeah, and it should give us the area. Let me just rub this all off and let's do calculations now. Alright, so 3 minus b plus 2b minus, let's just expand this. That'll be ax x squared minus 2x b plus b squared dx. 3 plus b minus 0 to b ax 3 minus 2abx squared plus b squared ax. Let me put that there. Have I done anything wrong here? Ax power 3 minus 2x squared ab, perfect, plus bax, yep, dx. So 3 plus b minus, it'll be ax4 over 4 minus 2ab x3 over 3 plus b squared ax squared over 2. Okay, from 0 to b. So 3 plus b is what? If we sub in b first, so it'll be ab 4 over 4 minus 2a b4 over 3 plus a b4 over 2 minus, and if you sub in 0, they all become 0, so that's useless. So just close the bracket. So 3 plus b minus, so just, I want to simplify this by just making it basic for myself. So if I multiply this by 12, so it'll be 3, 12, minus 8, 12 plus 6, 1 over 12. So it'll be AB 4 over 12. That simplifies to solid expression. And is that that? There's A here. So, but we know that A is what? What is A? A is 27 over 4b squared. So 27 over 4b squared, b to the power 4 all over 12. That simplifies to what? So 27 over 4b squared over 12, which is times 1 over 12. How many 3's can fit in this? This is 4a12, yep. How many 3's? 9. So we can say 9b squared over 16. Yeah. So this here can be written as 9b squared over 16. And I think it's the same as the expression on top. 9b squared over 16. Yeah, perfect. So this is your answer. We've shown units squared. Done. Perfect. All right. And I'm just going to nicely mark this. This is the last question. Perfect. Oh my god, I'm so tired. Wow. Find the value of b for which the area of the shaded region is a maximum. Wait, I'm supposed to actually just make this a function like a on b first. It makes our life easier for other calculations, so a on b. So we want to find the value for which the area of a shaded region is a maximum and find this maximum area. Okay, so we know that a on b is this over here. 3 plus b minus 9 minus, what happened? Okay, minus 9b squared over 16. Yep. So we know that a dash on b is what? 1 minus 9 over 8b, and a dash on b equals 0. So 1 equals 9 over 8 over b. So b must equal 8 or 9. So we know our b value. What's our, so we just want to sub that in. So 8 or 9, which will be what? 3 plus 8 or 9 minus 9. 64 over 81 over 16. So that'll be 3. So it'll be 3 plus 8 or 9. This will be 9 here. So it'll be minus 64 over 9 divided by 16, which is times 1 on 16. So 6, 12, 18, 24. So that this fits 4 times in there, so it'll be negative 4 on 9. So we can say this here is negative 4 on 9. Okay. Which is 3 plus, so 8 minus 4 is 4 on 9. So 27 plus 4, 31 on 9 units squared. Done. Wow. That was a quick walkthrough. But yeah, guys, I hope you enjoyed this video. I hope you learned something. This is how I would do this exam. I don't know if all the questions are right, so I'm going to have a look at the answers after this. I hope I got them all right. And yeah, so yeah, this exam was alright. I'm not gonna lie, it was quite nice. One of the nicest questions that I found was this one. It's quite new. Yeah, and this one over here, quite, you know, if you did special, this thing is, yeah, it's very, very easy to like see the pattern here. So that was nice, yeah. I hope you guys enjoyed this video. Make sure to like and subscribe, and yeah, for future videos, please have a good day and take care of yourselves. Bye bye.